This lesson is a follow-up to the lesson on the introduction to sets, and in this lesson we're going to focus specifically on the elements inside of sets. To continue our discussion on sets, I want to start with the exact same set that we talked about in the last lesson, which is the set of billiard balls. Now for starters, you can say that all of these balls are members of this set B. Or in other words, we can say that all of these balls are inside of the set B. For an element, there are only really two possibilities. Either the element is in the set, which we denote with this symbol over here, or the element is not in the set, which we write like this. In other words, it's outside the set. Now for example, this ball labeled 6 over here is actually inside the set B, and we would write this like this. So the way you should read this is that the 6 ball is inside the set B, or in other words, 6 is in B. Now aside from the outer set that I've drawn out here, it's also possible to draw other sets that live inside of B. So now that we've drawn this new set that I've labeled F over here, you can clearly see that this 6 ball is definitely not inside the set F, and we'd write that with this symbol that I've written here. Now, aside from talking about whether an element is inside or not inside a set, it is also possible to see that this set over here that we've labeled F is completely inside of this set that we called B. Now, it doesn't really matter how we actually draw these sets. I could have drawn F like this, and it wouldn't actually change the elements that are inside of it, because there are no elements here anyway. You would always call this set F a subset of this set B, because every ball inside of F is also inside of B, as you can see. To indicate that F is a subset of B, we write F is a subset of B. This symbol means is a subset of. This symbol is meant to look a little bit like the less than or equal to sign, and that's actually on purpose, because the whole idea is that F is smaller than B in some way. However, to make this more precise, the cardinality of F must be smaller than or equal to the cardinality of B. Now just in case you don't remember what the cardinality is, it's just a count of the number of elements inside each set. So just to say this in other words, we can say that F is the subset of B, or it's inside of B. And therefore you can also say that B is actually the superset of the set F, and that means it's outside of the set F. So when you read this, you can read it as F is inside of the set B. And that means if you write it in the opposite order, you can read it in the opposite way. Now it's a really good idea to think of subsets being inside of the set that contains them, but they definitely don't have to be drawn this way. So for example, take a look at this set. So I want you to notice that every single ball inside this set L is actually inside of this set B, because after all, the set B contains every possible billiard ball. We said that to have a subset, every item that occurs in the subset must also occur in the original set. And as you can see, every ball in this set L is also in this set B. And therefore, it's possible to say that L is a subset of B. Now I defined this set L to contain every single ball with a large number in it. I just randomly picked large to mean any number larger than 9. Now because there are balls in the set B that are not in the set L, such as the 6 over here, we cannot say that the set B is a subset of L. And just as usual, anytime we put a cross through something, that means not, so B is not a subset of L. Now, for one final definition, we say that two sets are actually equal if they contain all of the same balls. We said that this set over here contained all the balls with a number 9 or larger. I'm going to define another set that contains all of the stripy balls. So as you can see, every single ball that is stripy also has a number on it that is 9 or larger. So therefore you can see that every ball in this set L is also going to be in this set S. Another way to say this is that L must be a subset of S, because every ball that appears in L also appears in S. And, conversely, S is also a subset of L, because every ball that appears in S is also in L. We say that L is equal to S whenever L is a subset of S and S is a subset of L. Or in other words, every ball in L also appears in S and every ball in S also appears in L. And for this reason, we can say that L is not equal to B, for example, because whilst every ball in L does appear in B, not every single ball in B appears in L. Now you might remember that when you studied the less than or equal to sign, there was also a sign that's just less than, without the equals part. In a similar way, we have this sign for a subset, but then we have this thing called a proper subset. So as you can see, because this set D over here does not contain the ball 9, that means that D is actually a proper subset of this set S, and we would write that with this symbol over here. Just like the less than or equal to sign, by removing this horizontal line over here, we mean that the left side has to be smaller than the right side, and they cannot be equal. So we do the exact same thing for a proper subset. By going from this to this over here, we're just removing this horizontal line, and that means D actually has to be smaller than S. Or in other words, there have to be some elements in S that are not in D. So for example, whilst we can say that L is actually a subset of S, because every ball in L is also in S, we cannot say that L is a proper subset of S, for the exact same reason. Every ball in L is also in S. Or in other words, when two sets are equal, they cannot be proper subsets of each other. And that actually means that the cardinality of D actually has to be smaller than the cardinality of S, not equal to like it is for F and B. Now in this lesson, there was actually a fair bit of terminology, and it's going to take you quite a while to get used to all of this terminology, and you're only going to do that by doing a fair few examples where you try to figure out where things are subsets of other things. So to summarize this lesson, if you want to write that an element is inside of a set, you write this symbol over here to write, for example, 6 is inside of B. If you want to say that an element is not in a set, you use this symbol over here, because 6 is actually not in F. If every single element in F is inside of B, then we can say that F is actually a subset of B, as you can see over here. It's a good idea to think of subsets as being inside of the other set, but that doesn't necessarily mean that they actually have to be drawn that way. For example, L, as we said, is also a subset of B. If one set is a subset of another, then we can say that the cardinality of the subset must be less than or equal to the cardinality of the outer set. So therefore, when two sets are actually equal, they have to be subsets of each other. And then finally, we had the definition of a proper subset. And a proper subset is actually what you think of when you think of a set being totally inside of another set. A proper subset is actually smaller than the set that actually contains it. So this lesson was actually filled with a fair bit of terminology. But all of this terminology is quite important for you to learn if you're going to keep talking about sets. You'll see these symbols show up all over the place, and you should be pretty familiar with them to avoid being confused when you see them pop up. Now once you've gotten all of this terminology aside by doing a whole heap of questions on this, you'll be pretty comfortable, I hope, with all of these symbols, and then you won't really need to keep looking at them. But sets actually become useful when you build new sets out of old sets, and that's precisely the thing we're going to look at in the next lesson. So join me in the next lesson where we talk about operations on sets. Thanks for watching another Trina video. If you want to say thanks, you got to show your friends. Or maybe you should just visit us at trina.org, where you can track your progress and have access to questions and heaps of other awesome stuff. Or maybe you should just like and subscribe. That works too. But either way, I'll see you next time.